Hello everyone, this is Ketish here. In this video, I'm going to go through the 2018 Physics Higher Tier Paper 1 on the question number 4, which is on the energy topic. This is for the separate science physics group for AQA Physics. Question number 4, figure 5 shows a cyclist riding along a straight level road at a constant speed. Complete the sentences. As the cyclist rides along the road, the watt energy store in the cyclist's body decreases. Now that would be chemical energy. The speed of the cyclist is constant when the work done by the cyclist is what? The work done against air resistance. Now, when the speed of the cyclist is constant, that means the work done by the cyclist is equal to the work done against air resistance. If it was not, then the forces would be unbalanced. So either the cyclist would be decelerating or accelerating. Because the cyclist is moving at constant speed, it has to be equal. Next question, or question 4.2. Figure 6 shows how the speed changes as the power output of the cyclist changes. So you can see that the speed in meters per second goes from 0 to 15, but the graph line goes up to about 12 and a half. The power output is from 0 to 500. Question 4.2. Write down the equation that links power, time, and work done. Now, power equals the work done divided by the time. That's the equation which should be in the equation sheet. You can write the word equation or the symbol equation as well. Here the word equation is better. Question 4.3. Calculate the work done by the cyclist when his power output is 200 watt for 1800 seconds. So using the above equation, power equals work done. So if I write power equals work done divided by the time, rearranging that equation, the work done is equal to the power multiplied by the time. So the power is 200 multiplied by 1800. That gives me, so 200 multiplied by 1800, 360,000 joules. 360,000 joules. 360,000 joules. You don't have to convert it to kilojoules because the unit that they have given is in joules. Next question. Question 4.4. Calculate the percentage increase in speed of the cyclist when the power output changes from 200 watts to 300 watts. Now this needs to come from the graph. So what is the percentage increase when the cyclist increases the speed from 200 watt to 300 watt? So if I go back to the graph, make this slightly bigger. So at 200 watts, that is 9 meters per second, and at 300, this is just below 11. So I can, now that's 11 and just below 12. So I'll take it as 11.75. Right, it's slightly above 11.5. So 9 and 11.75. So at 200, it was 9 meters per second, and at 300 it was 11.75 meters per second. The percentage increase, so it's gone from 9 to 11.75. So if I take away that, I will ignore the negative value, which we will get 2.75 meters per second. It's actually gone up by 2.75 meters per second. So percentage increase as a percentage, 2.75 divided by 9, multiply that by 100 to get it as a percentage. So using the calculator, 2.75 divided by 9 and multiply that by 100, that gives me 30.5%. Now I should point out that in the marking scheme, the answer that they have given is actually quite different. Let me show you what the marking scheme answer actually says. They are saying 11 meters per second and 9.5. Now that I disagree with what's actually, yeah, this is definitely 9 meters per second, right? That you could argue, but this is definitely 9, so it's not 9.5. So I think the marking scheme is slightly incorrect. So let me bring that back into focus. And the range that they have given is up to about 16%. Ours is about 30%. The calculation is actually the same, right? So they've taken 11 minus 9.5. So ours is definitely above 11. So 11.75 minus 9, unless I'm making a mistake there. 2.75 is correct. So 2.75 divided by the power at 200 watt, which is 9 for us, multiply that by 10. So I'd still stick with this answer. It'll be worthwhile having a look at the examiner's report on this, but that's for us teachers. So let me remove that. So percentage increase is going to be 30.5%. Next question. The maximum speed the cyclist can travel on a level road is 14 meters per second. How does cycling uphill affect the maximum speed of the cyclist? Now, if that person is cycling uphill, so let's say a rough diagram to represent this. So if that's the level road and the cyclist is actually moving uphill there. So there you go, the cyclist. Right. That's 14 meters per second. Now, if they are moving uphill, right? If they're moving uphill, gravity is actually going to be pulling them down, right? As they move uphill, their GPE, gravitational potential energy, is going to increase as they gain height, right? So how does cycling uphill affect the maximum speed of the cyclist? Now, common sense or common experience says that the speed should decrease because you're going uphill. It's going to be harder. Give an explanation for your answer. Right? The explanation is because they have to do work against gravity. So here's an explanation. The maximum speed will be lower. This is because although the maximum power output of the cyclist is constant, so the cyclist is going to be able to produce a maximum amount of power output, and that's going to be constant. Additional work must be done against gravity as they climb uphill, causing the gravitational potential energy of the cyclist to increase. For 3 marks, you need to mention that what will happen to the speed. That's 1 mark. And that's 1 mark. And your explanation carries 2 marks here. Right? Although the maximum power output of the cyclist is constant, additional work must be done against gravity. This is key. Right? Must be done against gravity. Right? That brings us to the end of question number 4. I'll see you in the next question. Thank you.